Hey everybody, this is Larry. This is me going over Q3 of the weekly contest 324. Add edges to make degrees of all nodes even. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This problem is considered a hard in the point value, and really, I don't know that there's an approach to it. To be honest, the way that I thought about it is kind of the way that and I don't know if it is easy to teach. That's why I'm saying it in a really awkward way. But the way that I would think about it is kind of look at the constraints and really cater results and an algorithm for those constraints, right? And the biggest constraint that I see is here is not n is 10 to the fifth or even edges. It's actually at most 2 additional edge. Given this thing, then you can think about, okay, how do I add 1 additional edge and how do I add 2 additional edge? And for me, this was actually the hardest problem in the contest, because I think for me, I was just trying to prove a little bit. But other than that, it really is, you just have to be really careful about being exhaustive with all the cases. And that's basically what I'm going to showcase here. And this is my ugly code, but let me paint over it literally and then go over it one by one, right? So basically the idea is kind of brute force in a slightly smarter way. Oh no, did I lose my pen? Oh no, there it is. But basically, okay. So there are a couple of things that you have to kind of also just understand about parity, right? And this is just from experience doing a lot of problems, and yeah, I don't know that it. Yeah, I mean, I guess I can go over stuff that but of course during contest time, the more practice you are, these things that you don't have to prove to yourself, right? That's really what learning is for me, and in a way, I mean, there are all those also different dimensions of learning, of course, but it's about making these observations, proving them, so that you don't have to in the future. So anytime you see me going like, especially the live portion of this video where you see me doing it live, if you see me like very convinced about something, and well, there's some secret here is that sometimes that is wrong. So I'm also wrong a lot. But the other thing is that when I'm right, it's because I've done it before, and you could say it's a gut feeling, but it's a gut feeling trained by years of experience. You're almost like a machine learning, but for humans, right? But okay, so what I wanted to get to, and that's why I say all that because I'm talking about parity, right? And parity does funny things, which is that basically, okay, if there's no odd, so what I first do is I tally up the number of odd nodes with odd degrees, right? If there are no nodes with odd degrees, then you can return true. So that's a very easy if statement to write, hopefully. The other one is if there are odd number of odd nodes, then you cannot solve the answer. Then it's false, you cannot do it, right? And you could kind of see yourself that way, in that, let's say this is odd, you have 3 nodes, or you have multiple nodes, right? Let's say this is odd, and maybe I should turn it to. Let's say this is odd, and this is odd, right? And you can think about it as light switches or something like that, where you can only flip off 2 at a time. And if you flip off, because there are odd number of them, that means that all of them will pair up in some way, and except for one of them will be left behind, and you have to pair it with the other one. And if you flip this one, you also have to flip this one, and you always end up with an odd, with an exact odd node out, right? So and maybe this is obvious to some people, maybe it's not, but I'm articulating in a way that this is an observation that you just get from experience, and there are other things like that. But yeah, and the other thing is, of course, if you have more than 4 of these, if you have, let's just say you have 5 of them, right, and you only have 2 edges, well, that's pigeonhole or whatever. Maybe it's not pigeonhole, maybe it's just, I don't know. But if you have more than 4 odd nodes, it doesn't matter. You only have 2 edges, you can't fit them all together, right? So then the tricky thing is, what happens when you have two odd nodes, right? Oops. What happens when you have only two odd nodes? That's used to two on the left. Then what can you do? Well, then the obvious thing is try to connect them, right? If you could connect them, then you're already done. Then it's true. And you can only connect them if there wasn't an edge already, right? Basic idea, basic, I think that's straightforward. The one that I missed during the contest, and I probably rushed this a little bit to be honest, but the one that I got during the contest, if an edge already exists, keeping in mind that you actually have two edges that you can use. So the thing that you can do, and I didn't think this through, is just iterate all possible. Look at every other node and see if, look at every other node and see if you can draw two edges that way, right? Meaning that, let's see. I'm changing the color. That's so. Let's say that, let's say we have these three nodes. You can draw an edge from here to here and here to here instead, right? That will make this odd thing into even, this odd thing to even, and because this thing got two nodes, it would still keep the evenness, right? So that's basically the way that I would do it. And then the last case is, let's say you have four of them, right? And I wonder if there is a smarter way to do it, but the way that I did it is, to be honest, is just by brute force. I draw every possible edge between them, I draw every possible two edge between them, and see if see if they're good, basically. And that's and they're there are four nodes. So it's 4 factorial, which is, I don't know, 24 or something, right? You can probably even divide that by 2 because of the pairing, but yeah. Let me now look at the code, and maybe I could maybe I should put this here for a little bit faster, but well, because we're already matching that. But yeah, basically, all right, let's start from the beginning real quickly. This is to set up the edges. One index, I converted to 0 index just out of habit. I count the number of odd numbers, though it's the same as this, so maybe this could have been the way of this. But I was using it to debug later on. But yeah, so again, if there's no odd numbers, then your job is already done. You just add 0 edges and you'll be good. If there are odd number of them, like we said, it's impossible. And also, if you have more than 4 odd nodes, you just don't have enough edges. This is the 2 case. Basically, if they're not connected, then you just draw an edge between them and you're good. Otherwise, you see if there's an intermediate node that we draw in between them, and making sure that there isn't already an edge between the 2 of them and the extra node. And yeah, just return true out of that. And then otherwise, you can't do it. You only have 2 edges. This is the way to do it with 1 edge. This is the way to do it with 2 edges. Otherwise, you have 4 odd nodes, and basically I just do a maybe I could have done it with permutation or something, because this is actually 4 to the cube or something, or 4 to the 4, which is much slower than 4 factorial. But in any case, maybe I should have done it that way. Maybe that's my running time is okay though, so I don't know. But yeah, but basically it's just going, okay, if we check to see if we could connect IJ, and we could see if we could connect KL, just like, as long as we could connect them with 2 edges, we're good. So return true, otherwise we return false. And that's pretty much it. So what's the complexity of this one? It's going to be O of n plus some constant. This is O of n for number of edges. This or v plus y if you want to be more precise, because I guess we process each e, and then we also process each n like this in a weird way. And also O of n here. This is O of n, and this is O of 1, if you will. Because that's pretty much all I have for this one. So let me know what you think. Like I said, it's just about getting all the cases. You could that's all I have for this problem. So yeah, you could watch me solve it live during the contest now. Okay, so that was a yikes, but probably a lot of people made a mistake, but still, that's very sad. Maybe not, I don't know. Okay, so undirect the graph, UV, Okay, could be disconnected. You can add 2 edges. Return true, even. Okay. That seems easy, right? Oh, I know, because it's the even case. No. Maybe none. Well, in this case, I don't know. Man, that Q2 kind of does not make me feel good. Okay, so there must be at most 4. If okay, odd is equal to yeah, whatever. I'm just not thinking right today. If odd is equal to 0, then we return true. If odd is equal to 2, I have to take a look. If odd is greater than 4, then we return false, just because we can't do it. If odd equal to 1, we return false as well, because it's odd. So if odd is equal to 2, right, then we just check if for yeah, okay. I don't know. I probably could have. Okay, then if r sub 0 and y of r sub 1, then we return false. That means they already have an edge. Otherwise, we return true. If odd is equal to 4, then we need to add 2 edges. So then basically, okay, so now we have IJKL. If not in K, not in O, turn true. Otherwise, return false. Have we getting all cases? I think that's all cases, so I can just remove this maybe. Was it true, true, false? Yeah, okay, fine. Is it one indexed? Why must you hate me so? Didn't actually look at it, but true, true, false. All right, let's YOLO submit. Come on, big money. Oh, no. Today is not going to be a positive rating day, but it is what it is. Print so it's 2, 1, and 2. I return false. Oh no. Oh wait, no, I messed that up. It's 2, right? So print. E of R0. What was that force then? Did I misunderstood this? There's no repeat edges, right? And I think I did all the edges right. 0, 1, 0, 1, I. There's no way for me to see this. Wait, why did I return force then? So it's 1, 2, so this should be 2, 3 actually. Okay, so it's in there. Oh, I see. So then in this case, you can use 2 edges. Wow, that is a mess. Did people get really well on this? People got very good on this. I'm not. I see what's going on here. Okay. If this is not the case, then return true. Otherwise, we can also find what's n again? N is 10 to the 5th. Basically, we have to find 2 numbers that are not in what is the best way to do this? Wow, that is a good case. But basically, we want, oh, no, it's just 1 number, not 2 numbers. I messed it up in my head. And, okay, if I do and I do and I not in okay, where's the 1 bun? 1 time error, okay, fine. Oh, this is E of this. That is a good typo, or it's not a good typo, but it is a typo that allows me to solve this. Do I print stuff out? I do. Where's my print statement? No print statement. Let's go. YOLO. Hope that's all the cases. Okay, good. That is a tough one. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and how do you do on these problems and so forth. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.